Thank you very much. Hello, today I want to present our research about ocean plastic, a very hot topic at the moment. For us, this has been very significant for the last 5 years, and the project was kindly funded by the Carnegie Trust for the Scottish Universities under the Research Grant Incentive Scheme, so I would like to thank them for that. This is Ian and me on our first field trip on the Outer Hebrides, on the Isle of Harris, at a very deserted beach, sitting on an aluminium boat that had probably been there for 50 years. Ian's research, he's from a product design background, and he focuses a lot on in-situ manufacturing methods. And he'd visited the Isle of Scarp before the Isle of Harris in the summer of 2015. My background is in jewellery design. I'm a trained jewellery designer and goldsmith, but I work mostly in digital making, and I'm very embedded in that digital making culture. So around the same time, I became quite interested in how to use waste plastics from 3D printing, and had built my own filament extruder from a kit. So it was really quite an unfortunate convergence. Ian had seen a lot of plastics on the Isle of Harris, and we started talking about this project together and how we could come up with a way to use it in 3D printing. Now I think most people are really familiar with these types of graphics showing the ocean gyres, the various locations of the particularly bad accumulations of ocean plastics. These images, again, very familiar now after David Attenborough's Blue Planet series. The topic certainly became a lot more acknowledged in public and is very much at the forefront of everyone's minds now. But when we conceived the project from 2015 onwards, there wasn't that much general knowledge about the subject out there, and we found it quite hard to get funding. This is the islet of Scarp. Just outside on the Outer Hebrides. It's a tiny, tiny islet. It's uninhabited most of the time. I think the last inhabitants left in the 1970s. Some people have summer houses there, and I think there's one resident, a fisherman, who lives there until October, November time every year. So it is extremely remote. But you can see the Outer Hebrides are actually a fantastic place for ocean plastic research because of the shape, because of their position just outside Scotland. They act like a comb, and the ocean plastic sort of swirls in from out here and gets caught on the beaches that are facing the currents. And that's not all the beaches on the Isle of Harris, which was for me quite surprising. But there are some beaches that look absolutely pristine, sandy beaches where a lot of surfing takes place, and that is maybe what you see in brochures and when people go on holiday and post pictures of the Isle of Harris, but that's certainly not the reality of all the beaches we visited. So we got funding. We took ourselves off to the Isle of Harris in the summer of 2018, at the end of the summer actually. This is a view from the mountain on the islet of Scarp. So you can see here the sea loch, Loch Reasort in the distance. And it's quite a hike to the beach we actually ended up going, which was the first beach that Ian had scouted, the Mulmore. So you have to go, you can just about see some uninhabited buildings and the little port here. You have to cross in a dinghy. We were very fortunate that at the time of our visit, the sheep were being brought in. Sheep are the main inhabitants of the islet of Scarp during the summertime when they roam free, fatten up for the shearing, and then they're brought in by the farmers. And we were very lucky to be brought over by the fishermen and who were bringing the farmers over to catch the sheep, as it were. To get to the Mulmore, and I'm just going to point the Mulmore out again here. You have to go over this little mountain, so that's the sort of settlement area here, and that's the mountain. You have to kind of hike over that. There's no paths or anything. I'm not much of a hiker, so for me this was a little bit out there. Ian's very sporty, so he just did it. I was lagging behind a little bit there. But this is a view I took from the top of the mountain when I was taking a wee break from the hiking. And this is the Mulmore here. You can just see it looking pristine and beautiful from afar. And that is another thing about ocean plastic. It's there, but you can't necessarily see it until you're right on the beach and right on top of it. And this is a picture Ian took in 2015. That's what he first saw. And it's certainly a massive shock when you do get there, as someone who's never seen the problem in person. He found out from locals that the variety of objects had declined since the early 1990s because New York stopped dumping its rubbish in the sea. This is not something we could substantiate, but it is something the locals observed from their experience with the ocean plastic problem. And that's the model more today, and that's what you can see when you get there. These big bags here were signs that some plastic collection had taken place by the locals. So there are some drives to clean up the beaches locally. And what the locals do is they visit the beach, they go and pick up the rubbish, they put them in these huge bags here. And then they have to leave it because there's no way to get it away. And they hope that the fishermen come. You can see as well the beach is very hard to access from the sea level. You have to clamber over lots and lots of pebbles before you get to the actual rubbish bags. So they're kind of dependent on the local fishing industry helping out a little bit there. But what happens most of the time, and we reckon this rubbish collection probably took place about a year before we got there, the rubbish gets left in these big bags. And then it redistributes when the storms hit from September onwards. And the beach just goes on, and the plastic just goes on and on. A lot of the waste we found was from the fishing industries. You can see crates here, smashed up, some fully intact. Some are being reused by locals for their own purposes, private purposes mostly. Lots and lots of fishing buoys of all ages, rope, but also some sort of domestic waste, probably chucked overboard by passing boats. And of course, there's no way to tell where the rubbish has come from. It just accumulates, it sits in the sea for a long time, and then it gets swamped up into the beach. And the pebbly nature of these beaches actually makes it quite hard to remove because the storms come, the pebbles get pushed on top of the plastic waste and bury it in a sort of a layer. So to remove it all, you'd have to unseat the pebbles and get the plastic out from under it. And this is a problem that reoccurs every year, basically. So yeah. So that's just the Isle of Harris, so Scarp's up here. We were staying around here where we visited a few beaches. Hushnish Beach is actually completely untouched. There were very, very small bits of plastic there, but it's quite sheltered in a way because of this tongue of land here. And then we went all the way down this coastal road here, and Sheelebos, that's one of the most famous beaches on Harris, beautiful, pristine, sandy beach. And both, but we heard there was quite a lot here on Northern, and we eventually ended up down here in Rodau, where we found again a large accumulation of plastic waste. And you can see that people actually live here. They live right next to the beach. For the locals, they have become so used to seeing the plastic. They don't feel it's a problem for them. It's just there. It's just a feature of the landscape now. They don't necessarily feel it's something it's something for them to live with. And actually, a lot of the plastic picking up drives were conducted by so-called incomers, people who had just recently, and by that I mean probably within the last 10 to 15 years, started living on the island. And then here we found more objects. Again, you can see as well the seaweed gets entangled. There's quite small parts, small bits and pieces, and they just get left. Rubber gloves, rubber boots, a toilet seat, brushes. We found it all. It's all out there. And this particular net was quite interesting, a huge, probably reusable type of fishing net. It was too big for us to cart off. As soon as you take responsibility for the rubbish by picking it up, it is your responsibility. So in theory, you're responsible for taking it away and recycling it or repurposing it in some way. So if you pick something up and then you set it down again, you're technically littering the beach. So this was quite a large rope. You can see it's right by the coastal inlet here. When we returned to this beach in March 2019, the rope it was still there. This is the same huge net, but it had moved from around here to the back of the beach, where it will probably still be sitting. So if anyone fancies a huge fishing net, there it is. We saw a lot of evidence of plastic being buried inside the soil, being swallowed up, and this is one of nature's ways to deal with any kind of problem, growing on things over it, swallowing it back into the soil, and reabsorbing it into the earth. But of course, with plastics, especially oil-based plastics, they don't degenerate ever, essentially, so it just sits there. And the same goes for rope. I mean, something like this would be practically impossible to remove without digging it out. And that's nylon mostly. Most of these ropes are made out of nylon. And crates. There's quite a lot of boggy marsh on Harris, just a feature of the landscape. And plastic waste just sinks into these bogs and disappears, or so we think. We were very lucky, very fortunate that the fishermen, so we boarded their dinghy at Hushnish, and they agreed to take us out to the various sea lochs. So we went into this little inlet here, and then up Loch Tamarbang, and this is where we found the boat, the aluminium boat, on one of these beaches. We alighted and found another beach full of plastic, essentially. But I think what was more significant was the fact that along the rocky shores of the coastal line, there were pieces of ocean plastic everywhere, sometimes lodged underneath very, very big rocks. And the part of the project was really to survey what types of issues there were with the ocean plastic, to bring back some samples to analyze what types of plastic we would find. This is something that hasn't really been looked at massively. A lot of the research out there is about marine currents and distribution, but not very much about the materiality of the actual plastic that is being found and what state it's in once it's been out there. And this is by the beach where we were living, by the cottage we were living in, and you can see here it's stratified. A bit of the beach had broken away. This was in March again on our second field trip, probably in the storms throughout the winter, and you can see the different strata of things having been absorbed, plastics having been absorbed into the soil. And then from above, it just looks like a grassy verge. So it really has become part of the fabric of the land. In this case, and that's obviously the most difficult to deal with plastic waste. And just another little collage of all the different things we saw, all the different kinds of objects we found, an old oil drum, welly boards, you name it, it's out there. Some tape. We found a whole box of unused rolls of sellotape. Some old cassette tapes, hopefully not containing any secret information and having been dumped in there. But we took about 40 samples back with us from this field trip and took them to the lab. My side of the research was very much sort of centered around exploring how these materials could be used, analyzing them. We were very fortunate to have a research assistant with a material science background. I strongly believe in the arts and the sciences collaborating together to generate new knowledge to take forward. And this was a sort of a brush-like object we found made from polypropylene. And you can see immediately some of the problems are the scale of it quite small, 15 centimeters, and some of the problems are quite obvious immediately, even for the filament generation later. There's quite a lot of dirt lodged in the bristles. There's a little bit of marine growth on the actual object. And again, using photography as a research method is something that's quite close to my heart. So I'm very invested in macro photography, so I took images of most of the samples at different magnifications, and this is approximately 3 times. And you can see the plastic starts to break down. This is the same object from the previous slide. It starts to scale off. These little things here are little scales. That dirt gets trapped underneath, and they flake off eventually. And this is then, of course, what causes microplastics to seep into the water table. So these objects they're in the sea. They get attacked by the salt of the water. Then they're washed up onto the beach, and that's almost worse because they start to photodegenerate, and UV light is actually 1,000 times worse for the actual plastic than being inside the sea. So in a way, they're a little bit preserved while they're in the sea, and then they come on land and start to, they weaken and they start to degenerate even more. And that's just another close-up of sort of the dirt that accumulates between the bristles. And there's lots of these samples. This is from a big crate. A little bit of a larger sample actually, but you can see even more how degenerated that is. And different types of color pigments degenerate in different ways as well, so that was quite interesting. Our research assistant analyzed these with various material science tools and machines, and then the data from that we haven't really used yet because, we're not from a material science background. We don't really know what to do with it, but hopefully this is something that we can attack in the future. This is another larger HDPE sample. Again, sometimes the function of the objects we picked up was quite mysterious. There's a slight problem here with two materials having been combined. You've got a little jump ring made from metal, some kind of metal. And on the HDPE samples, we found that there were large amounts of marine growth. So you can see them being colonized by these roots from lichen, probably, or some sort of marine organism. And again, that also embeds much more dirt into this particular type of plastic, but also raises issues of species migration. We don't know where these plastics have come from and what species they might introduce to our shores. And again, that's something quite interesting maybe to investigate a bit further. And this is another object just like that. So you can see quite dramatically here how the pebbles are sort of underneath the marine growth. And our research assistant found when she started washing the plastic, so for the extrusion process, the plastic has to be washed, it has to be granulated, it has to be dried out in a dehydrator, and then it gets extruded through a big piece of equipment. My particular interest was really how can we make this process available to makers? I feel very much as a maker, and I think Ian as well. How can we make this available, for instance, in local maker spaces, in men's sheds? And this was something we really wanted to look into. And then the buoys we found, they're made from polystyrene. They're not suitable for the kind of extrusion process we're using. So actually polystyrene is extremely hard to recycle in any kind of way. So I'm not sure what the best way is to deal with those other than maybe to redistribute the ones that are still fully functioning. Not this one, this is actually a broken one, but there were some that were fully intact. Oh God. Right, better hurry up. Okay, so we returned in March under great difficulty. The weather was completely against us. We almost didn't make it, got caught in two snow blizzards, rewrote via Aleppo. You can see the beauty. This is a beach near Schelabos, so you can see it is absolutely pristine. We took some sand samples from this beach, which have yet to be analyzed. But we returned to do some public engagement workshops with the local school that we had made contact with on our first field visit. And then from yesterday, I was quite interested in the talk about how can we engage, how can we bring our research to schools like this. And what we were thinking about was, so we designed this three-dimensional map of the island, 3D printed, for the school children to really get a sense of the geography, to point out maybe some ocean plastics that they'd seen. We brought in 3D printing pens. We extruded filament with them to kind of really make them understand how plastics as a material is developed. A lot of them weren't aware of that, how this whole process works, and how it relates to them personally in their everyday environment. So you can see here in the background our extruder going. We couldn't use the ocean plastic in the school room environment because of extraction issues, which would have been our ideal scenario, to go out to the beach with the children and extrude this, but in this case it wasn't possible because of extraction. And then we 3D printed small parts of the island that they had chosen as a special place of meaning for them from the freshly extruded filament plastics, and that's where they're choosing it from all our different tiles. And we did these workshops in both Tarbert High School on Harris and at Mallaig High School on the Scottish West Coast, because these are two locations that are very much affected by the ocean plastic problem. And that's just some of the little printed tiles and the filament we made. And I think that the children really got a lot out of it. We talked about our research to them. We also did 2 public engagement events with the locals where we had discussions about what they had seen, how they felt about the ocean plastic problem, what we had seen, what our perspective was. So we were really trying to get that sort of two-way communication going. We also took our research to the RTD 2009 conference in Delft in March, and here we were able to use the makerspace with sufficient extraction. We had brought some pieces of ocean plastic, granulated them with the participants, immediately clogged up their granulator, so that went well. But we actually managed to extrude some filament. You can see it's a little bit inconsistent because of some remaining moisture inside the material. And then the participants designed things, and they decided on jewelry. This wasn't necessarily me influencing them in that direction. And they calculated, this is the 26.8 kilo ring, they calculated that this, at that point, would have been the amount of plastic each of us would have to pick up to even make a dent in the ocean plastic problem. And that's where we are now, so thank you very much. And if anyone's interested, I've brought a spool of the filament with me. What's quite interesting about this is once we had made the filament, it still smells of the sea. There's still small inclusions in there. And so anyone who wants to have a look at it is very welcome to do so.
Hi. Hi. I was just wondering, when you went from taking the plastic from the beach and then obviously breaking it down and using it for the filament,
Yeah.
did you have any complications with, did the plastic degrade at all before you went to make it into filament? Or was there any problems with there being other materials that compromised the structure of the plastic when it went to try to make it into filament again?
Yes, so to our great surprise, this wasn't the case. That's what we had anticipated. I mean, I showed the sample with a little bit of moisture remaining in it. That is probably the worst enemy that you have. There's also questions around how much should you wash it. You're using clean water in terms of sustainability. It's not great to wash the plastic you found for hours and hours under a running tap. So you've got to find a sort of a trade-off between, 3D printing filament in particular has parameters of having to fit through the 3D printing nozzle you're using. But actually, no, we mixed in a little bit of PLA to add a tiny bit of virgin plastics to make it work a little bit better. But both the PP and the HDP we used produced some usable filament. So, yes.
This is on, right? It was a really great presentation. One of the things that, the images were really wonderful, but one of the issues that I found is there's a picture of you and Ian, and you had, I think it's a water bottle, which was made out of plastic.
Right.
And in your research, when you're looking at the materials you've found, the ocean plastics, have you done an analysis on differentiating the materials in terms of not their physical properties, but rather the way in which people use them? There were crates used by fishermen, which are used over and over again, and then you have water bottles, which are just single. I mean, I have a water bottle, but I've used that for many days, which is also not healthy. And so, does your research tackle that issue of single-use plastics, or is this? Well,
we were mostly focused on the plastics that we found on the beach. I personally do reuse my water bottles many times. I think the research indicates it's not quite clear what the plastic that gets into our bodies actually does to our bodies. Some people believe it just passes right through us. Some people believe it causes cancer. I'm not sure about that. So I think single-use plastics, in a way, if they are collected well, for instance, water bottles. They're a little bit easier to reuse than the plastics we found on the beach because they won't have all those issues of particles being inside the material and marine growth having to be washed away. So I think as design researchers that it would be fantastic to tackle all these problems, but also we have to sort of forge out the niche that where we can make a difference.
Can I just ask one more question really quickly?
Maybe. We've got 3 others, and then so maybe you can ask over lunch.
Over lunch.
Apologies if you mentioned this and I missed it, but what material is in the filament, and are you able to mix different plastics, or do you have to identify a specific one?
Yeah, so we try to avoid mixing different plastics because obviously once you mix them together, it's very hard to extract them. But for the filament extrusion process, it's extremely important to have a tiny percentage of virgin plastics. Otherwise, the filament won't actually be usable for 3D printing. So in this case, what we did, we added PLA to the plastics that we found, which is biodegradable. It doesn't biodegrade on a compost heap in 10 years, but in an industrial composting facility, it does degrade quite quickly. And outside in 100 years, which is still a lot better than oil-based plastics. So that was our idea of mitigating the environmental impacts of the ocean plastic we were using.
Hi, thanks.
Hi.
I thought that was absolutely fascinating. Really, really did, and extremely eye-opening as well. I come from a coastal region, and I can completely identify with the whole thing about how plastics become normalised, and then over recent years we've been like, oh no, it's not normal, it's not good.
Yeah.
And some of your images were startling and really valuable. And I was just wondering, I was thinking about circular economies and materiality in particular. So I know in Cornwall there's a couple of businesses that make kayaks and also swimwear out of recycled fishing nets. And I was just wondering if you could talk a little bit about the commercial opportunities. I believe that both of those companies, I think that they have to go to Denmark. They have to take the nets they gather to Denmark in order to make it into a usable plastic. But I wanted to do with
I think there's a big drive now to try as much as possible in terms of what kinds of applications this sort of plastic could be used for, the things we find on the beach. And a lot of the nets are made out of nylon, which I think for textiles works really well. So I'm quite glad that there's a lot happening now because this is such a huge problem. For me, the most problematic things are the buoys that are they're very, very thick. They're extremely solid. They have an inside shell of about 5-6 millimeters. So they're even very hard to break down in the granulator. So I wish that there was somewhere, maybe even some kind of collection mechanism for the functioning ones that was then redistributed to local fishing businesses who could reuse them. So a lot of the problems happen with the collection mechanisms that are currently not in place, as it were. So I think if we could make some inroads there to educate locals and to kind of put some good solid collection mechanisms in place, that would be a really good start.
Hi, thank you very much for that. It was a great presentation. And we've seen over the course of the 2 days quite a few really interesting projects that have a lot of impact with a small cohort of participants. And my question really is to the room, is how can we extend the impact of these very small, very successful projects to a wider audience?
That's an amazing question. We're going to reuse that question. I think there's huge there's other questions around it. I think it's a question of scalability, and I guess we've all kind of struggled with that. So let's hold that. Anyway, you got an answer?
No. I'd love to have an answer.
I'll need to think over lunch, but I think we should come back to that right at the start. Actually, it's a great question. So, I can't believe it. It's lunchtime. We've made it.
Thank you.